We're going to take a look at a series parallel combination circuit in the Rule 1, Rule 2, and Rule 3 for solving it. And so what we have here is we have a voltage source that's going to produce a current because we have resistance here in a complete circuit. And it's going to go through this first resistor that's in series with these two parallel resistors. So we have a series parallel combination circuit. Okay, so the first thing we're going to do is we're going to start with Rule 1. Rule 1 says, look for any two resistors that are in series, and if you have those in series, you want to reduce them. Well, we don't have any two that are in series, okay, so we can't do Rule 1. So we move on to Rule 2. Rule 2 says we look for any two that are in parallel, okay? So we do have some in parallel. These two right here are in parallel, okay? So what we need to do is we need to reduce this parallel into a circuit, okay? So this parallel, to become a single circuit, is going to be 1 over RT is going to be equal to 1 over R1 plus 1 over R2, okay? And so we're going to take 1 over 4, so 1 over RT is going to be equal to 1 over 4 plus 1 over 4. So 1 over 4 plus 1 over 4 is equal to 2 over 4, okay? That's what we've got. So because this is the reciprocal, we have to flip this up. We have to flip this and we have to flip this. So we get RT, because we flipped it, is equal to not 2 over 4, but 4 over 2, which reduces to 2 ohms. So we flipped both sides to get the 2 ohms, all right? So now what I'm going to do is I'm going to redraw this circuit in a simplified version. And so I still have my first R1 right here, which was 8 ohms. But now these two parallels became 2 ohms. So we put the 2 ohms right there. Okay, so now we go to, we did Rule 1, we couldn't find any series. We did Rule 2, and we found a parallel and reduced it. And now Rule 3 says go back to Rule 1. All right, we'll start again. Do we look for two that are in series? Yep, we do have two that are in series. These two are in series. So these can get reduced. So once again, I'll draw this circuit again. Okay, and I have 12 volts. And we know that when you're in series, you get R total is equal to R1 plus R2. So my R total is going to be equal to 8 plus 2. 8 ohms plus 2 ohms. My R total is going to be equal to 10 ohms, okay? So there I have my R total. And because I'm now at my most simplified circuit of this with just a single voltage source and a single load, I can get the current here. And I know that I is equal to V over R, which is 12 volts over 10 ohms, which is 1.2 amps. So that is what flows through here, 1.2 amps. I can then start working backwards and solving this because I know that, you know, the 1.2 amps stays the same in a series. So as I work my way backwards here, I know that this becomes 1.2 amps, and this is 1.2 amps. 1.2 amps, okay, because it stays the same in a series, and this is just the reduced version of these two. 8 plus 2 is 10, okay, and so now I can solve for my voltage here, okay, using Ohm's law. And then I can work that backwards, and then these two, you know, the voltage stays the same, and I can solve this whole circuit along those lines. But it starts with Rule 1, look for series and reduce. Rule 2, then look for parallel and reduce, and then start again and keep drawing and simplifying as you go, okay? And we'll do a more complicated one here next.